right, welcome to geology, everybody. Let's talk transform faults, the last one that's on that chart, and maybe they're like maybe a little less interesting in cross section. Not that they're less interesting overall. That's up to you. But let's look and see what we're looking at here, and then see why maybe cross section there's less to see. The most famous transform plate boundary that we're going to mention because of where we live is the San Andreas. So this chunk of California is migrating that way relative to that chunk. In fact, your textbook has a pretty cool picture of this bridge right here where it says now entering the North American plates. If you cross that, so you're standing over here on what will be the Pacific plates. Yep. And then you cross this bridge and you go into the North American. And the book says that it's designed to like shift on the foundation, which is kind of neat because this woman in the orange shirt here would be destined to head that way when this thing goes off if she were able to stand still for a really, really long time compared to that person over there. So what if I were to look at this from the side? That's where I'm saying maybe there's like less to see. I mean, like this is the surface. We'll make it a little flatter. And the fault just kind of goes down, right? On one side, if we do the San Andreas one, it would be going, this is hard to draw. This would be like an arrow. It would be going straight into the page right there. Whereas on this side, it'd be coming like straight out of the page at us that way. So that's why cross section, this is kind of useless to see. So if you want to ignore that, please do. So what is cool about them is if we look from the top, we can say there's two different types. There's this type here that we're seeing. So let's say that this fault were to go off and have a significant displacement, like right there. And these people safely made it through it, and they were watching each other the whole time. If this person's looking at this person, which way did they go when this thing moves? And again, if I can draw on a pen, this woman in the orange shirt's going to go that way. But if you're pointing at the person across the bridge, where do they end up? That's the part that's tricky to see here. Okay, so let me draw that right over here. Right over here. So if we look straight down on those people, right? Here's the fault. Here's the bridge. It was a great drawing. Here's the top of that woman's head in orange. We'll use orange for the top of her head, right? Now, yeah, she's going to go that way when this fault happens. That means that the person over here who was wearing, let's say, a blue shirt, I don't remember, is going to go this way. So here's how to solve these things. If you look across, and this is this woman's right arm and her left arm, which way does that person on the other side of the fault go? What do you think? They move to the right. So this is called a right lateral transform plate boundary in this case, or if it's a smaller scale, strike slip fault. So if you're doing your little notes, the pressure is not towards or away. That's our divergent or a convergent. Now we have that like shear thing happening where one's sliding one way and one's sliding the other. The result is transform faults, strike slip faults. And then the only difference between them that we'll get down is this right lateral versus left lateral one. So if we hypothetically had another one somewhere else on the planet, that is the case in San Andreas, by the way. If we had another one somewhere else on the planet, and again, if this person were to go that way, meaning the person on the other side appears to go that way, now they've moved off to our left. That's a left lateral transform faults. What the heck? Let's throw these occasionally gets called Bextral. You know, like the old school thoughts that people will right hand. I don't know if you know any of this. This is like if you go to old school schools where they would beat you with a ruler if you wrote with your left hand. People that were right-handed were considered dexterous and skillful. And then these awful people down here, a left lateral. We're called sinistral. Sinister, awful people, right? Not, of course, not really. But that's the idea with those. All right, let's check the book, see if there's anything else. So yeah, the last part we'll mention is that these are often found around mid-ocean ridges. So here's an ocean ridge that has this small tectonic plate that gets subducted underneath North America. So there's a lot going on here. The red line is your mid-ocean ridge, divergent. The blue line is a oceanic to continental convergence. And now these green lines are transform faults to offset that bit of plate motion. Now it's hard to have a plate split open perfectly on spherical planets. It doesn't really work very well. So all of these offset that pressure caused by that. Same thing over here. Pop over to the Mid Atlantic, and you can see all those little green lines there, all the transform faults. And if you turn it off, I mean, they still show up if we don't have those lines on there. Spreading on that side, and then offsets at those transform faults. All right, easier one, but those last five are the trickier ones. So hope those went well. More soon. Take care.